Morning, welcome everybody. May I request Air Marshal Jagdish Singh sir, Senior Vice President KFA, to please come to the stage.
Jai Hind and Namaskar, ladies and gentlemen. A warm welcome to all of you on this little chilly morning. On behalf of Air Chief Marshal E.R. Chaudhary, President Air Force Association, and all members of the Air Force Association, I extend a very warm welcome to all of you. Unfortunately, Air Chief Marshal Chaudhary couldn't make it today. He was in Nasik day for yesterday for a function and he had to go back to Hyderabad. So he requested me to continue with the function today morning. So on behalf of him and the association, once again I extend a very warm welcome to all of you. We are in fact honored that we have Chairman DRDO and Secretary DND with us, who's kindly accepted our request to deliver today's talk. In addition, I would like to share it with Qatre lecture, which is co-hosted by HAL. So this time we requested SBI to be the if they could be, so they have agreed. So I extend a warm welcome to AVM Saini, who is the Defense Banking Advisor with SBI, Mr. Ashleen, Abhishek Das, and Priyanka Madam, who are also here with us. Thank you very much for being here and being the co-host with us. Sir, we are very much a big part of the Indian Air Force, and as Indian Air Force starts any function with the Air Force song, so we also have made it a practice that we will start all our functions with the Air Force song. So now I will request all of you to please rise for a minute, and the wordings of the song will be displayed on the screen. I will request each one of you to sing along. Thank you very much. Please be seated. Where we'll have today's function in this sequence. Where a welcome address, I will request Chief Marshal Budhuria sir to do this honor on behalf of Chaudhary sir. Then he'll request Dr. KAMAT to come and give his talk. We all know that DRDO has been doing a wonderful job. We've been reading about it, talking about it, but today we are honored that we are going to hear it directly from Dr. Kamath, who is the Secretary DND as well as Chairman DRDO. Thereafter, after his speech, there will be a small honoring ceremony for the Chairman as well as the SPI dignitaries. And thereafter there will be a vote of thanks, followed by a group photograph, and thereafter we request you for joining us for a cup of tea. I now request Chief Marshal Bhaduria sir, who has been our President Air Force Association earlier, to come and give a welcome address for the speaker.
Dr. SAMIR Kamath, Chairman DRDO and Secretary DDRD, Air Chief Marshal AP Singh, Air Chief Marshal Deputy Sir, all the senior leadership of the Indian Air Force here, all the serving people, my colleagues and veterans, ladies and gentlemen, very good morning. On behalf of President AFA and all the members and all the serving personnel here, all the people here, I extend a very warm welcome and a very big thank you to Dr. Kamath for agreeing to address us and give this memorial talk. Because firstly, this memorial talk is very close to our heart in terms of organizing, in terms of the kind of topics and the kind of attention we want to give. Because this is in memory of Air Chief Marshal P.C. LAL, who's been one of our most illustrious chiefs, and who was at the helm of Indian Air Force in 1971 and scripted the golden chapter in the history of Indian Air Force when in the Indo-Pak conflict of 71, we registered unparalleled and a decisive win, and Bangladesh was born. You all know the details. I don't want to go into it and take more time because I want to keep maximum time for Dr. Kamath. But Air Force has always the kind of legacy that was and the vision that was scripted by Air Chief Marshal P.C. LAL has been with us, and we've all cherished it, we've all worked towards it over generations. We've all moved in the same trajectory and taken it higher and forward. And IF has always striven to be ahead in the technology curve, to innovate, to do the impossible. And in that sense, I think we are really honored that Dr. Kamath is agreed to address us all and also give us a sense of what is happening and what challenges face us and how are we going forward. So thank you again, Dr. Kamath, and just to introduce him briefly, again I will not take too much time. He's had a checkered career in his build-up towards learning and towards DRDO. He is an alumnus of IIT Kharagpur, did his PhD in USA, and thereafter in 88 and joined DRDO in 89. He did his PhD in material science and engineering, and in DRDO he was, in the same field of materials. While we talk a lot about how materials is one of our most important vulnerability, he has worked relentlessly many years on many projects and delivered materials which have become indigenous. And of course, he has worked on many DRDO projects before he took over the reins of DRDO, and has provided very calm and very firm leadership to DRDO and the labs in these times and rapidly changing scenarios and technologies. So without any further ado, I would request Dr. Kamath to kindly share his talk with us and do the honors of sharing his knowledge and sharing his vision and where are we headed. Thank you very much.
Am I audible at the back? Air Chief Marshal AP Singh, Air Chief Marshal Dipnis, Air Chief Marshal Bhaduria, Senior Leadership of the Air Force, serving and veterans from Air Force, ladies and gentlemen. A very good morning to all of you, and it's indeed a privilege and honor to deliver the Air Chief Marshal P.C. Lal Memorial Lecture. And I'm indeed grateful to AFA for inviting me here and giving me this opportunity. At the outset, let me pay my respects to Air Chief Marshal P.C. Lal. As Air Chief Marshal Baduria mentioned, he was at the helm of the Air Force in 1971 when the country won a decisive war. So I think his leadership, his vision for the Air Force has resulted in the kind of capabilities that today's Air Force has. The topic that I have chosen today is defense R&D, challenges and the road ahead. So let me start with the brief introduction. The world we live in today is in a phase of transition. We are in a state of geopolitical churn. We are moving from a unipolar world to a multipolar world. And India is going to be one of the strong poles in this emerging multipolar world. This is because of the size of our economy, the size of our population. Our rise cannot be stopped. We are also living in a world where technology is changing very rapidly. Earlier, you could take 10 years, 15 years to develop a technology. It would still remain state of the art for the next 15 years. But today, that is no longer the case. You can't afford to take that long to develop a technology because the technology itself is getting obsolete in 5 to 10 years. We are also living in a world where a lot of new disruptive technologies are emerging. AI, ML, quantum technologies, photonics, these are having a disproportionate effect on the weapon systems. In fact, in all our lives also, these technologies are rapidly affecting how we live itself. We also have nature of warfare itself is changing quite dramatically. Earlier wars was being fought only on land, air and the sea. But now space, cyber, information, these domains are emerging. And if you ask me, before any major conflict starts, you're going to have cyber and information warfare dominate, which will hamper your logistics, your ability to fight a conventional war. The warfare is also becoming network-centric. The use of autonomous platforms is increasing. And of course, to avoid collateral damage, we need precision strikes. We also have ambition as a nation. Our Honorable Prime Minister has given us a call that we should become Atmanirbhar. He has also set as a goal that we should become a developed country by 2047, Viksit Bharat as he calls it. And he has also given us a challenge that we should become a technology leader, and especially in defense technologies. So these are the nation's goals which we have to consider going ahead. Now, if you look at the present defense ecosystem, you have three pillars. You have basic research, which is usually done in academia. You have applied R&D, design and development, and you have production. Today, if you look at our ecosystem, we work in silos. The overlaps are minimal. Of course, there is a fourth pillar, which is the user, which also has to get integrated in the three pillars. So if you look at broadly, defense R&D mostly done in DRDO. Of course, there is some support from academia and MSMEs. Design and development of systems also happens mostly in DRDO, though this is changing now. A lot of PSUs and industries have started design and development. And production, till very recently, till the defense sector was opened up, used to happen either in PSUs or ordnance factories. Now private sector is getting in, but mostly this production happens based on TOTs either from DRDO or from abroad. So this is broadly the defense R&D ecosystem today. However, we have not done badly even though we are working in silos. Today, I would say, if not full self-reliance, we have fair degree of self-reliance in all the areas that I have listed: missile systems, armored vehicles, military bridging systems, artillery, guns and ammunition, light combat aircraft, helicopters, ships and submarines, AEW&C, radars, EW systems, sonars, torpedoes, to name a few. We don't have complete self-reliance. For example, in the light combat aircraft today, the dependence on aero engines still exists. Similarly, we have dependence on semiconductor chips today because we don't have any chip manufacturing in the country. All our electronic systems, we are still dependent on foreign countries. Certain materials such as carbon fibers, so any composite, our dependence on foreign sources still exists. So although we have achieved fair degree of self-reliance in these fields, we still need to focus on some critical elements which keeps our dependence on foreign countries. If you look at the systems which are likely to be inducted in the next few years, you have the Anand Shastra, which is the QR SAM. You have the guided Pinaka. You have the advanced lightweight torpedo, the trawl assembly, infantry floating bridge.
3, 2, 1, now.
You have the long-range land attack cruise missile. You have the long-range anti-ship missile. You have the Akash anti-system, the air-to-air missile Astra Mark II. So in the next 2-3 years, we should have several systems inducted. We have the light tank. We have the high-endurance autonomous underwater vehicle. The very short-range air defense system, the naval anti-ship missile, the Rudram 2 air-to-surface missile. So in spite of our working in silos, we have achieved quite a bit, and in the next 2-3 years, several new systems will also get inducted. Now, if you look at the defense capability pyramid, we have today established capability in system configuration and design, system engineering and integration, system testing, evaluation, qualification and certification, in the development of subsystems, in the development of components, device manufacturing, in machine tools, fixtures for manufacturing, as well as materials development for production at scale. So we have built capabilities in all these 7 areas, but there is lack of capacity. If you have to fight a sustained war, you also need, in addition to capability, capacity to produce at scale in a very short period. So although the defense capability pyramid now in the country is fairly good, we need to look at how we can build capacity. So if you now look at what challenges do we face today, defense is a monopsony business. There is usually only one buyer, and this is true globally, not only in India. So we also have to focus on exports. Till very recently, our focus was only on how we can provide for our services. But unless you look at exports, it's very difficult to sustain a defense business. I'm glad to say that last year we exported about 23,000 crores worth of defense equipment. And Honorable Raksha Mantri has set us a target of 50,000 crores by 2029. If we have to sustain defense R&D, defense production in the country, exports have to be looked at very seriously. The other challenge that we have is we have a very long trial cycle and a very long acquisition cycle. Till we had only DRDO, PSUs and ordnance factories in this business, that was okay because our salaries were being paid by the government. But now that private sector is getting in, if this is not shortened, it is going to be very challenging for them to sustain. Because if it takes 4 to 5 years after you finish development to get your system inducted and to generate cash flow, it is very difficult for any industry to sustain. So this is one challenge that we have to look at, how we can shorten our acquisition cycle, how we can shorten our trial cycles. We have to look at accepting simulation as a way of testing. Everything need not be tested experimentally. As I had mentioned earlier in my talk, we don't have full control over our supply chain, especially semiconductors, some of the materials. These sometimes have a very long lead time, which then cause delays. So we have to address our supply chain. We have to build a robust and diversified supply chain. And all critical items, we have to see how they can be produced in the country, or we have to have the tie-ups globally. A serious problem that we are facing is in talent. Today, talent is at a premium. People are willing to pay very high salaries to acquire the best talent. Today, government organizations face the challenge, especially in these new areas such as AI, to attract the best talent. Because the kind of salaries they get in the civilian domain is so high that in communication, in electronics, in AI, we are finding the brightest people are not coming. So this is again, and as a country, we are encouraging the global capacity or global capability centers in the country. Our brightest talents are working for foreign companies where the IP then belongs to that country. They are not working for technology development for the country. So this is again a challenge which we have to overcome. The next is, as I said, capacity. Because of our acquisition process, which wants competition and selection by L1 method, no no company is willing to set up capacity. They are not sure that they will get the next order in that domain. So they say, why should I set up capacity? Only once I get an order will I set up capacity. It's not a sustainable model. If you look at US has only Lockheed Martin and Boeing looking at, aircrafts and missiles. Very few. Russia has one or two companies. We cannot encourage competition to an extent where we don't build capacity or capability in a given company. So this is again a challenge which we need to overcome. So far, we have avoided this civil-military fusion. We have kept our defense R&D separate, civil R&D separate. Because of sanctions in the past, after our nuclear explosion in Pokhran, we had sanctions. So we had kept our civilian R&D, defense R&D, which was then subjected to sanctions separate. Unfortunately, we continued that trend once those sanctions were removed. If you see globally, there are a lot of domains where now the civilian sector is far ahead of the military sector. If you look at communication, AI, the civilian sector is far ahead. Unless we leverage the expertise and the technologies developed in the civilian domain, our military technologies will not be up to the mark. Again, one big challenge we have is lack of risk appetite in the country. And this is not true. This is true not only in the government sector, but even in our private sector. Everyone wants risk-free investment. They want return on investment within 3 years. If you want to do cutting-edge R&D, you have to look at taking up riskier projects. Only then can you achieve technology leadership. Culturally, we are also intolerant of failure. In government, we get audited saying that you have caused loss of money to the exchequer if your R&D project fails. So what that does is you take up only incremental R&D. There, the chances of failure are less. You may get delayed, but your chances of failure are less. Unless we encourage failures, you have to fail fast. You learn much more from your failures than you learn from your success. So we have to bring in this culture of I would not use the word promoting failure. You should encourage people to take chances, even if they fail, as long as genuine efforts have been put in. You should not penalize a person who takes high risks. We all admire DARPA, but if you look at DARPA's projects, the success rate is 10 to 15%, but they address moonshots. So their technologies which come out of DARPA projects really change the nature of the field in which these technologies are developed. We have to encourage that kind of culture. You need incremental R&D, of course, but you also have to encourage high risk taking in R&D. Then the ease of doing R&D, you must have heard of ease of doing business. Similarly, we have to improve the ease of doing R&D in the country. Today, we treat R&D the same as we treat acquisition or procurement. You have to follow the same methods because we treat R&D as the same. You know everything what is going to happen. So you have to go by the L1 method. Unless we improve the ease of doing R&D, we will not attract the best talent to do R&D. We will not get the best results from the R&D we do. So this is again what we need to do. So for this, we have to address our GFR. Unless we address this, these challenges are not going to be overcome. Then, although we want to be a technology leader, if we look at our funding for R&D, it is very poor. If you look at the R&D spend as a percentage of GDP, India lies at 0.65%. And if you look at our competitors, they are all more than 2%. South Korea, in fact, spends 4.8% of their GDP on R&D. This is overall R&D, not defense R&D. And as I said, a lot of the civilian R&D now is becoming increasingly relevant for defense R&D. Even in the 0.65%, it is mostly done by the government sector. 70% of the total R&D funding is by the government. Only 30% is by the private sector. And this too only happens in a few sectors such as pharmaceutical and now in IT space. This has to change if we have to become a technology leader. Even if you look at our defense R&D spend, India spends about 5.5% of its defense budget on R&D. If you look at US and China, they spend between 10 to 15% of their defense budget on R&D. And their budget is much higher than our defense budget. So if we have to catch up with them, it is going to be very challenging unless we increase the percentage of our defense R&D spending. So what is the net effect because of these challenges? We have delays in the design and development. We have delays in production because we don't have control over the entire supply chain. And the net effect is we are followers, not leaders. It is going to be very challenging to catch up in conventional domains because they are already 10, 15 years ahead and they are spending more than you. So it is now absolutely necessary that we look at how we can use disruptive technologies to catch up. We need to leapfrog, or not only leapfrog, even pole vault if you have to achieve technology leadership. And this can only happen if we imbibe or develop these new disruptive technologies and use them in our defense systems. Otherwise, it is going to be a Herculean task because you are already 10 years, 15 years behind them. So what is needed, the graph which I showed, you need much more overlaps between the academia, DRDO, and the R&D design development establishments and the production. And you need much more involvement of the users with all three. This is what we need going ahead.